Okay, so today we're taking a deep dive into something maybe a little more cerebral, a little more intellectual than some of our previous episodes.
Definitely. But also maybe more relevant than you might think at first glance.
Right. Like when we say demonstration, folks might be picturing, marches and protests and things like that.
Right, right, exactly. But we're actually talking about demonstration as a form of logical proof.
Yeah, a very, very specific kind of proof, the kind that, well, medieval thinkers, they believed this was the absolute gold standard for unlocking real scientific knowledge.
Yeah, they were really serious about this. And, for our listener out there, the philosopher always seeking a deeper understanding of things, this is going to resonate with you because this isn't just about, medieval logic. It's about getting to the very heart of how we know anything, for sure.
Exactly. And to guide us through this intellectual labyrinth, we're turning to a fantastic resource, the Stanford Encyclopedia of Philosophy, and specifically their entry on medieval theories of demonstration.
Yeah, this is a great overview. It takes us all the way from Aristotle's foundational ideas in the posterior analytics up to the 16th century. So
Mhm.
it's a pretty comprehensive picture of how these ideas evolved over time.
So our mission in this deep dive is to unpack some of the core concepts and, the big debates surrounding demonstration in the Middle Ages and really zero in on the aspects that are going to be most interesting to a philosopher, someone concerned with the nature of knowledge, the nature of proof.
Exactly right.
Okay, so let's start at the beginning. It seems like pretty much everyone in the Middle Ages was in conversation with Aristotle when it came to this topic, specifically his work in the posterior analytics.
Oh, absolutely. Aristotle is the foundation here. And for him, a demonstration wasn't just any old syllogism. It had to be a very specific kind of argument that led to scientific knowledge.
Right, so it's not just about knowing that something is true, but also understanding why it's true.
That's the key, knowing why, understanding the causes, the reasons behind things. He was really focused on.
So it's like peeling back the layers to get to that core essential truth.
Exactly. And Aristotle believed that just like, causes in the real world are ultimately rooted in the nature of things, so too must our scientific explanations start from first principles that are connected to the real definition, the essence of the thing we're trying to understand.
Right, so it's about understanding the nature of a thing in order to explain why it behaves the way it does.
And that really contrasts with some more modern approaches that might focus more on, functional definitions or operational definitions for Aristotle. It's all about that underlying essence.
Now, the source mentions that Aristotle's logic wasn't always the best fit for things like mathematics, with relational concepts. How did they deal with that?
That's interesting, right? They were actually aware of this limitation and they kind of worked around it.
Worked around it. How so?
Well, Aristotle used this idea of ecthesis. It's like a kind of informal setting forth of a specific case from which you can then infer a more general truth.
So, like using a particular example to illustrate a broader principle.
Exactly. It's kind of similar to how you might see a proof in mathematics, where you start with a concrete example to show how the theorem works.
Okay, that makes sense. So the formal logic was the framework, but they had this more flexible tool for dealing with these more abstract areas.
And another key thing for Aristotle was that the principles of demonstration had to be universal, reflecting necessary connections, but not just any kind of universal. They had to be what he called commensurately universal.
Commensurately universal. Break that down for me.
Okay, so it means that the predicate, the property you're talking about, has to belong to the subject in every single case, and it has to belong to anything else because it belongs to that subject.
So not just because they both happen to fall under some broader category.
Right. It's about that very specific connection between the subject and the predicate.
Okay, I see the precision there. And the source also lists some key criteria for what they consider to be a true demonstrative science. It talks about understanding terms, knowledge of axioms, first principles, real definitions. It seems like a pretty high bar.
Oh, it was a very rigorous standard for knowledge.
Yeah.
They believed that to have real scientific understanding, you had to grasp these fundamental building blocks and first principles, those indemonstrable truths specific to a particular field, were absolutely crucial.
So these first principles, what were the requirements for those?
They had to meet some pretty strict criteria. They had to be true, obviously, and indemonstrable because that's what makes them first principles.
Right. Can't prove the starting point.
Exactly. And they had to be explanatory.
Yeah.
They had to actually explain the conclusion. They had to be necessary, and they had to be per se.
Per se, that's a term we're going to hear a lot in this deep dive, and the source highlights two major medieval interpretations of that term.
Yeah. Those interpretations were at the heart of a lot of the debates that followed. So for Aristotle, per se, could mean a few different things. But the two that became most important in the Middle Ages were first, if the definition of the subject somehow included the predicate.
Okay, so like the classic example, a human being is rational.
Right, because the very concept of a human being includes the idea of rationality. And the second way was if the definition of the predicate implicitly included the subject as the proper kind of thing,
Yeah.
to have that attribute.
So like a human being is capable of laughter.
Exactly.
Yeah.
Laughter is seen as a property that's specific to human beings. It flows from our nature.
And these distinctions, they might seem kind of technical, but they're actually getting at something really fundamental, right?
Yeah, they're grappling with the question of what properties are truly essential to a thing's being and which ones are maybe more contingent or accidental. It's a question that still resonates with philosophers today.
Absolutely. Okay, so one is about essence, and the other is about a necessary attribute that comes from that essence. And then there's the middle term in a demonstration that's the crucial link that connects everything.
Right. The middle term is key. It has to express the cause, the reason why the predicate belongs to the subject in the conclusion. So it's not just saying that they're connected, but explaining why they're connected.
And this leads to another important distinction that the source brings up, demonstratio quia and demonstratio propter quid. Can you unpack those terms for us?
Sure, so demonstratio quia means demonstration that it is the case. It can establish a fact, but it doesn't really explain why that fact is true.
Give me an example.
A classic one is the idea that stars are distant because they twinkle, and anything that twinkles is distant.
Okay, I see the logic there.
But the thing is, the twinkling doesn't actually cause the distance. It's the other way around. The twinkling is an effect of the distance.
So it's just a correlation, not a causal explanation.
And that's what demonstratio propter quid is all about. It's a demonstration why it is the case. It goes from the cause to the effect and provides a real explanation.
So one is just showing a connection, the other is uncovering the underlying mechanism.
And, that distinction is still relevant today. We see correlations all the time in science, but figuring out if there's a real causal relationship, that's the challenge.
Absolutely, and it's something that these medieval thinkers were very concerned with. The source also mentions this concept of subalternate sciences. Can you explain what that means?
Yeah, so subalternate sciences are basically fields of knowledge that borrow their principles from a higher science.
So like a hierarchy of knowledge.
Exactly. The example given is medicine using a geometric principle to explain why circular wounds heal more slowly.
Oh, that's interesting.
So the physician doesn't have to prove that geometric principle themselves. They can rely on the authority of geometry as a higher science.
Makes sense. Okay, so we've laid some groundwork with Aristotle now. Let's dive into how medieval thinkers engaged with these ideas, and the source points to Robert Grosseteste as a pivotal figure.
Oh, absolutely. Grosseteste was really influential. His commentary on the posterior analytics around 1230 was a turning point in how these ideas were received.
And he even applied the methodology of the posterior analytics to itself, right?
Exactly. He argued that it constituted a demonstrative science of demonstration. He saw Aristotle laying out definitions and then deducing the properties of demonstration through rigorous logic.
So a science that analyzes the very nature of scientific proof. That's fascinating. And how did he fit this in with the prevailing Augustinian views on knowledge at the time?
That's a really important point. Grosseteste was able to present demonstration as a necessary tool for humanity, especially in our fallen state.
Fallen state meaning?
Well, Augustine had this Neoplatonic view of knowledge where you could directly apprehend God or the natural world within God.
Like a kind of mystical vision.
Right, but Grosseteste argued that this ideal was largely unattainable for us, after the fall.
Due to our limitations.
Exactly. So demonstration became the accessible path to knowledge for us in our current condition.
It's like an intellectual workaround for our impaired understanding.
And, Grosseteste was a bishop, so his endorsement of these Aristotelian ideas really lent them legitimacy within the church.
Right, it made them more palatable to a wider audience. Okay, so what were some of Grosseteste's specific contributions to this theory of demonstration?
He had some really interesting ideas about how we acquire knowledge of causal laws. In particular, he proposed this faculty called estimatio, which is like a kind of sensory apprehension of causal connections.
Can you elaborate on that?
So imagine you observe that a certain herb consistently produces a healing effect.
Okay.
This estimatio would give you a sense of a connection there, a link between the herb and the healing.
Like a gut feeling based on repeated observation.
In a way, but then reason steps in and suggests experiments to test that connection.
To isolate the cause and see if it holds up.
Exactly. So if the herb still produces the effect when other potential causes are removed, then reason can conclude that it truly has that causal power.
And he saw this process as analogous to how we form universal concepts from our experience of individual things.
Right, it's about moving from the particular to the general, from the senses to the intellect.
And he also made a key distinction between formal and material definitions.
Yes, this was fundamental to his understanding of natural science. For him, a formal definition specifies a thing's function, and it involves its final cause, its purpose.
And a material definition.
A material definition describes how the thing is structured, its efficient cause, so it explains how it achieves that function.
Okay, so like with a saw, the formal definition might be a tool for cutting, and the material definition would describe the blade, the handle, the shape.
Exactly. He saw these formal definitions as connected to exemplary forms and material definitions as their realization in the physical world.
Interesting. And where did mathematical demonstrations fit into all of this for Grosseteste?
He actually placed mathematical demonstrations on a higher level than natural science.
Why was that?
He believed that we have a direct intellectual grasp of mathematical truths, like the properties of a triangle.
Without needing to consider things like efficient causes or final causes.
Right, because for him, mathematics deals with eternal, unchanging truths.
Whereas natural science is dealing with the messy world of change and causality.
And since mathematical truths are more directly accessible to the mind, he considered their demonstrations to be superior, more certain.
And his concept of subalternation was closely tied to his metaphysical views as well, right? Particularly his ideas about light.
Oh, absolutely. Grosseteste had this whole system where light was the fundamental principle of the universe. It propagated and organized itself according to mathematical laws.
So a very mathematically structured cosmos.
And this led him to the idea that natural science was subalternate to mathematics, because math governs how light manifests in the world and structures the physical realm.
Okay, so there's this hierarchy where higher sciences influence the lower ones.
Exactly, and he saw a similar relationship between biology and natural science, where living things arise when higher forms impart specific functions to matter.
So it's all interconnected for him, logic, science, metaphysics, all tied together by this concept of light.
But not everyone agreed with his interpretation of subalternation in particular. Albert the Great and Thomas Aquinas had some strong critiques.
Right, they were coming from a more strictly Aristotelian perspective.
And they took issue with Grosseteste's metaphysical grounding, and they proposed their own interpretations of the posterior analytics.
So what were their main points of contention?
One of the big ones was this idea of subalternation and the role of mathematics in the natural sciences. Albert, for example, rejected the idea that a substantial form acted as an exemplar for matter, or that natural things were somehow based on mathematical being.
So he was pushing back against this kind of Platonism.
Right. He argued that the unity of a thing comes from its own specific substantial form, not from some higher mathematical unity.
And that each science has its own distinct subject matter.
Exactly. Albert was very much about the autonomy of different fields of knowledge.
And didn't he also disagree with Grosseteste about the example of harmony?
Yes. Grosseteste had argued that the science of harmony was subalternate to the science of proportion, because harmony is essentially a kind of proportion in sounds.
Right.
But Albert countered that the true explanation for harmony lies within the science of sounds itself.
So it's about understanding the specific properties of sounds.
Exactly. And while you can describe sounds using mathematical ratios, that doesn't mean that the science of proportions defines the essence of sounds.
They're fundamentally different things.
And for Albert, nature operates according to its own principles.
So it's not beholden to some higher mathematical order.
Right. He believed that if nature exhibits mathematical regularity, it's because of God's design, not because it's trying to imitate some pre-existing mathematical form.
And Aquinas was largely on the same page with Albert about this.
Yes. Aquinas agreed that different sciences have their own subject matter, and that Grosseteste's account of subalternation was flawed. But he added an important nuance.
What was that?
He said that mathematics does relate to the physical world because matter inherently has quantitative properties like dimensions.
Okay, so there's a connection there.
But for Aquinas, these mathematical properties exist in matter because of the nature of material substance itself, not because of some separate mathematical reality.
So it's coming from within the material world, not from some outside influence.
And there was another key difference between Albert and Aquinas when it came to whether a thing's essence could directly cause its non-essential properties.
Right. The source points this out as a subtle but important point.
It gets into some deep metaphysical territory. Albert was very cautious about saying that a thing's essence could efficiently cause its attributes. He was worried about veering into Platonism, as if these separate forms had a direct causal role in the world.
So he saw the attributes as arising from other attributes or from external factors.
Aquinas, on the other hand, argued that a thing's nature does efficiently cause its primary attributes, those attributes that flow necessarily from its essence.
But he was careful to say that these attributes are often potentialities or capacities, not always fully actualized qualities.
Right, so it's not like these attributes are always present in their complete form, but the potential for them is there because of the thing's essence.
Okay, I'm following you. And this disagreement about the role of essence in causation, it led to a big debate about the demonstratio potissima, right?
Yes, the highest or most perfect form of demonstration. Aquinas, following his view on essence, argued that in the demonstratio potissima, the middle term should be the real definition of the subject.
So the explanation goes right to the heart of what the thing is.
Exactly. But Albert, sticking to his more Aristotelian framework, said that the middle term should be the definition of the attribute, what's called a causal definition.
So focusing on explaining the attribute itself, not just connecting it back to the essence.
And the interesting thing is that Aristotle's own writing in the Posterior Analytics seems to lend more support to Albert's position.
So Aquinas had to reach a bit further afield to support his view.
And then you have Giles of Rome coming in and staunchly defending Albert's interpretation.
And he had a pretty strong objection to Aquinas' view, right?
Yeah, he basically argued that if the middle term is just the definition of the subject, then the major premise becomes kind of tautological.
Meaning?
It would be saying that the definition of the attribute belongs to the subject because of the subject's essence, which is basically just restating the definition of the subject.
So it's circular reasoning.
Right. And for Giles, a demonstration has to provide new information. It can't just be repeating what's already contained in the definition of the subject.
That makes sense. And how did Aquinas' supporters respond to this objection?
They brought in this distinction between different types of concepts we can have of a thing. So there are quantitative concepts, which are those perfectly captured by the real definition.
And then there are.
Non-quantitative concepts, which are more general or based on our sensory experience.
Okay, I see the distinction.
So they argued that a demonstration of the highest sort would connect the quantitative concept, the real definition, to a non-quantitative concept, thereby providing new knowledge.
So it's not just repeating the same information.
Right, but Giles, he wasn't convinced by that. He countered that even those more general concepts ultimately refer to the same underlying reality as the real definition.
So for him, it's still ultimately a tautology.
He maintained that the definition of an attribute is more informative because it refers to things outside of itself, namely its causes.
So it expands our understanding beyond just the subject itself.
Exactly, and this whole debate really highlights the complexities they were dealing with, about the nature of definition, the nature of essence, what makes a truly meaningful explanation.
Okay. And now let's bring in William of Ockham. He comes at this from a nominalist perspective. So how did that influence his understanding of demonstration?
Well, Ockham agreed with Scotus and Aquinas that the definition of the subject should be the middle term in the highest form of demonstration.
Okay.
But he was skeptical, like Albert, about the idea of essence efficiently causing an attribute, and he really emphasized the importance of real distinct parts within the subject itself.
So for him, a genuine demonstration has to be based on the actual structure of the thing.
Exactly. He was very much a realist in that sense.
And how did this affect his views on different types of definitions?
Well, for Ockham, a genus difference definition, which doesn't identify real distinct parts, couldn't be used as a middle term in the highest form of demonstration. And this had a big implication. It meant that for Ockham, no demonstration about God was possible.
Because God is considered to be simple without parts.
Right, but he did see a special case in mathematical definitions.
How so?
He argued that mathematical definitions, like the definition of a triangle, indirectly convey the parts of the subject without explicitly stating an identity between the whole and its parts.
Okay, so it meets his criteria of being based on real parts.
Exactly. And for Ockham, this became the only way to achieve the highest form of demonstration. It satisfied all of his requirements for a truly informative and certain proof.
So mathematics has a kind of privileged status for him.
Definitely. And when it came to natural science, he had a more nuanced view. He allowed for demonstrations of certain negative attributes based on the separable parts of a thing.
Okay, give me an example.
So like arguing that anything composed of separable parts is therefore destructible.
Right, because the parts can be separated.
Exactly. And he also talked about demonstrations concerning concrete individuals like animals or humans, which he believed had multiple forms. But he didn't consider those demonstrations to be of the highest sort because they were about the composite whole rather than the pure substance itself.
And what about demonstrations based on efficient causes?
He limited those to hypothetical conclusions about specific instances.
So less about universal laws and more about what happens in particular cases.
And he completely rejected demonstrations from final causes. He saw those as always reducible to efficient causes.
So quite a departure from Grosseteste on that point.
Right. And he actually reinterpreted Grosseteste's framework for the science of demonstration to emphasize efficient causal pathways.
So it's the same structure, but with a different focus.
Exactly. He argued that a good demonstration should follow the natural path of our cognition, from knowing the premises to knowing the conclusion.
Okay, so we've talked about all these different theories of demonstration, but it all comes back to this fundamental question. How do we come to know those first principles in the first place?
Right, the starting points for all of this knowledge. And this is another area where there was a lot of disagreement among medieval thinkers.
So let's break down some of the different views, starting with Grosseteste.
Grosseteste, as we mentioned earlier, had two main ways of knowing first principles. For those principles where the predicate is included in the definition of the subject, he believed that we arrive at them through a kind of intellectual vision of the thing's real nature.
So based on our sensory experience of particular instances.
Right, and for causal principles, he proposed this idea of estimatio, where we apprehend causal connections through repeated observation, and then reason leads us to more general conclusions through experimentation.
So it's a combination of empirical observation and intellectual abstraction.
And Aquinas had a more intellectualist perspective. He believed that grasping the substantial nature of a thing directly reveals both its definition and its primary attributes.
So it's all about understanding the essence.
Exactly. And he saw these primary attributes as flowing directly from the substantial form which we grasp through intellectual insight.
Okay, so more top-down approach.
And then you have Scotus, who leaned more towards empiricism. He agreed that some causal principles are known through definitions, but he believed that others require experiential grounding.
So observation is key for him.
And he had this famous saying, whatever occurs in many instances by a cause that is not free is the natural effect of that cause.
So he's looking for patterns in nature.
And Occam takes this even further. He argues that we can know the causal power of a specific kind of thing from observing just one instance.
Based on the assumption that nature is uniform.
Exactly. And he famously stated that the real definition of a simple substance doesn't tell us anything about its effects.
So we have to learn those through observation.
And that really anticipates some of the core ideas of early modern empiricism.
Wow. So we've covered a lot of ground here, a lot of really intricate ideas and debates. So for our listener out there, the philosopher grappling with the nature of knowledge, what do you think are the key takeaways from this deep dive into medieval theories of demonstration?
I think the most important thing is to appreciate the incredible depth and rigor of these medieval thinkers. They were really serious about understanding the foundations of knowledge, and they tackled some of the most fundamental questions about causality, essence, the relationship between different areas of knowledge, the nature of certainty, all issues that are still relevant to philosophy today.
Absolutely. And we've seen a wide range of perspectives, from Grosseteste's emphasis on light and metaphysics to Scotus and Occam's more empirical leanings. And these debates, they show us that there's no easy answer to these questions about how we know what we know.
And they remind us that these are age-old questions that philosophers have been wrestling with for centuries.
So it's not like we've somehow moved beyond these fundamental challenges.
Right, we're still grappling with them, just maybe in different ways.
Yeah. So here's a final thought for our listener to ponder with all of our scientific advancements today. Have we truly transcended the core issues that these medieval thinkers were wrestling with? Or are we still essentially dealing with the same fundamental questions about the nature of explanation, the role of essence, the foundations of knowledge, just dressed up in a different language?
I think that's a question worth reflecting on, and I would encourage everyone to explore the works of these thinkers for themselves. They offer a rich historical perspective on the pursuit of knowledge, a pursuit that continues to this day.